So the next chapter then is going to be chapter 12. So it deals with probability stuff. And so first off, we can call the counting principle. Basically is the number of possible outcomes for an event. So you think in terms of tossing a coin. The outcomes are either heads or tails. You think in terms of rolling a dice. The outcomes are the numbers from 1, 2, 3, 4, 5, and 6. So given this, given a person has 6 pairs of shoes, 12 pairs of pants, and 20 shirts. And I want to know how many different outfits are possible. So how many different outfits? And so we got, well, for shoes there's 6, pants there are 12, and then the shirts there are 20. And so here we'd have 1,440 different ways this could be done. Well, in terms of counting, we can have either with or without replacement. And so let's look at what that would mean. So let's say, given the letters of the alphabet, given the letters of the alphabet, how many 4-letter codes, 4-letter passcodes are possible? So first off, first, without replacement. So without replacement, that would mean we have 26 choices for the first one. We have 25 for the next, 24 for the next one, and then 23 for the one after that. So if we multiply all those together, we find out there are 456,976 possible ways we could do that. And then if we do it, sorry, that should be without replacement. And if we do it with replacements, well, if we do it with replacement, well, there's 26 for the first one, there's 26 for the next one, and 26 for this one, and 26 for that one. Because each time we're saying, okay, we could throw the letter back in the hopper. And I'm sorry, I wrote the numbers backwards. This number is not correct. That is actually the one for this one. 4, 5, 6, 9, 7, 6. And this one would be 3, 5, 8, 8, 0, 0. Right? Right? Right. So counting principle. So the next thing then deals with permutations and factorials, permutations, and combinations. So first off, factorial. And the symbol you'll see for that on your calculator will most likely be in terms of this exclamation point. And so you have in terms of something called n factorial. So for example, if we had 5 factorial, what that means is 5 times 4 times 3 times 2 times 1, which in this case would be 120. Okay. And then if I had something like 12 factorial divided by 9 factorial, well, we could say this is going to be 12 times 11 times 10 times 9 factorial over 9 factorial. And then that and that goes. And so we're left with the 12 times 11 times 10. And this comes out to be 1,320. So permutations and combinations. And so first off, permutations. So in permutations, you have that the arrangement of the objects is in a definite order. So here in permutation, order matters. So the order does make a difference here. So if you think in terms of if we had a lock, so I have a lock that has the numbers 1 through 12 on it. Okay. And my combination for this lock is made out of 3 numbers. And those numbers have to be in a definite order. And so the question then is, how many different ways can this be done? So on your calculator, somewhere you'll find a key that looks like this, NPR. Okay. So that is the button or the key you're going to use when we do these type of calculations. So N is the number of items. R is how many you're taking at a time. So here we have 12 things taken 3 at a time. And so we find here there's 1,320 different possible ways this could be done, given that. Okay. And then the other type then is combination. So in combination, you have that the order does not matter. Okay. So that's the difference. Permutation, order does. Combination, the order does not. So an example, the prime example of that is you think in terms of playing cards. And let's say we're dealing out a 5-card poker hand. And let's say I deal out the ace, 2, 3, 4, 5 of clubs. Okay. That would be a poker hand. That would be a very good poker hand. So let's say now I shuffle the cards. We deal out another hand, and this time I deal out the 2, 3, 5, ace, 4 of clubs. Well, that is the same poker hand. They are the same. Right? And so those two would be the same hand. And so combination, you have order does not matter. And so you get to the question, and that is how many 5-card poker hands can be dealt from a standard deck of cards. Standard deck of cards. And standard deck has 52 cards. So this would have 52. So for this is going to be a combination. And so now you'll be looking for this on the calculator. And it'll probably be near the same area where you found the NPR key. And so now this would be 52 things taken 5 at a time. And so this comes out to be 2,598,960 possible poker hands can be dealt from it to get the cards. So permutation and combination. Again, permutation order does matter. Combination order does not matter. So then again, in terms of probability. And so let's look in terms of this, hopefully. So I have here in terms of a chart dealing with rolling 2 dice, right? So rolling 2 dice here. So the probability of an event is the number of elements that are E, okay, over the total number of elements. So let's look in terms of my dice chart. And I want to know what is the probability of rolling a 7 given 2 dice, right? So the probability of rolling a 7 then is going to be given along this diagonal. Right in there, right? And if you count those up, you'll find out that there are 6 there. And then the total number of outcomes, well, this is a 6 by 6, so there are 36. And then, of course, this fraction could be reduced. And again, fractions we have to reduce if possible, right? So let's look at another one then. And so now I want to know what is the probability of rolling, of getting a 9. And so the probability of a 9 is going to be given along this diagonal here. And so you have 1, 2, there's 4 there. And so this is going to be 4 out of 36. And of course, that could be reduced to 1 over 9. Right? So again, the probability of event is the number of times that E occurs divided by the total number of it occurring. Right? All right. Well, as long as I have my chart here in front of me, What we said that the probability of rolling a 7 is 1 out of 6. So what is the probability of not getting a 7? Of not a 7. Okay. Well, there are 6 numbers that are 7, so that would mean that there would be 30 out of the 36 that are not. And of course, this would then be 5 out of 6. Okay. So it ends up then that the probability of the event, so the probability of E plus the probability of not E equals 1. After all, 1, 6. So if you think in terms of the numbers we just did, the probability of E, we said it was 1 out of 6. The probability of not was 5 out of 6. And that does indeed equal 1. Right? All right. So probability. So you have a connection then between probability and odds. Right? So odds and probability. So the probability of E then basically is A over A plus B. Right? And then the odds in favor of E is going to be the right? And so this is going to be the probability of E over 1 minus the probability of E. Right? So let's go back to our dice. So we said the probability of a 7 was 1 out of 6. So the odds then of getting the 7 are going to be the probability of E, which was 1 out of 6, over the probability of not getting that, so that's what 1 minus PE, which we said was 5 out of 6. And if I simplify that fraction, and let's do it out, after all, this would mean 1/6 divided by 5/6. And if you remember your fraction, we said we leave the first one the way it is, change the sign to multiplication, and flip the second one over, and then that and that will go away, and we're left with 1 out of 5. So we have in terms of the odds of getting the 7 is 1 out of 5. Right? Well, in terms of events, we can talk about if they're exclusive or not. So we got in terms of mutually exclusive events. So mutually exclusive events are events that cannot occur at the same time. So you think, or you cannot occur at the same time, or have no influence. So you think in terms of, first off, my probability of rolling a 7 given 2 dice. Okay, which we said was 1 out of 6. And then I go, okay, what is the probability of drawing a king given a standard deck of cards? Well, there are 4 kings out of 52 cards, so this is 1 out of 13. Okay? So then I want to know what is the probability of getting a 7 or a king. And so this is going to be 1/6 plus 1 out of 13. And of course, these are fractions, and are that fractions, we need to have a common denominator, which in this case will be 78. So this is going to be 13 over 78 plus 6 over 78, and we end up with 19 over 78 for that, right? So, exclusive event, but what about events that are not mutually exclusive? So let's look at that. So not mutually exclusive now. And so now we have this, that the probability of A or B is going to be to the probability of A plus the probability of B minus the probability of A and B. And let's make this B a little better. Right. So let's look in terms of this scenario then. So I have a spinner. And it's going to have the numbers 1, 2, 3, 4, 5, 6, 7, and 8. And I have my spinner. Color. Something like that. All right. So I have a spinner, and I want to know in terms of this. Right? So I want to know what is the probability of getting an even number or number less than 4. Okay. So first off, let's say the probability of A. And A is going to, this is going to be my even number. So if I look at my spinner, the even numbers we have, this is going to be 4 out of 8. Okay. Probability of B. And so probability of B, and this is going to be less than 4. And this number would be 3 out of 8. And then lastly, the probability of A and B. So even number, that is less than 4, and that is only going to be my number 2, and so this is going to be 1 out of 8. So now the probability of A or B is going to be the probability of A, which we said was 4 out of 8, plus the probability of B, which is 3 out of 8, minus the probability of A and B, which is 1 out of 8. And so 7, this is going to be 6 out of 8, which of course could be reduced to 3/4. Okay. So conditional probability. So if A and B are two events in a sample space. And a sample space really is all the different outcomes that are possible. Then the conditional probability of B given A has occurred so the probability of B given A is the probability of A and B over the probability of A. So given something like this, so we have some probabilities. So I'm going to say the probability of A is 0.7. The probability of B is 0.4. And the probability of A and B is 0.25. And I want to know what is the probability of B given A. And so this is going to be 0.25 over 0.7. So 0.357. And we could do this the other way. And so now I could say, okay, what is the probability of A given B has occurred? And so this time this would be 0.25 divided by 0.4, and this comes out to be 0.625. And then lastly, we get to probability of successive events. Successive events. So given this, so let's say we have a box. It has 4 red, 3 white, and 5 green marbles. And we're gonna pick 3 marbles. Without replacement. And I want to know what is the probability we get a red followed by a white followed by a green. So the probability of getting the red one, well, there's 12 marbles in the box altogether, so this is going to be 4 out of 12. Right? Now the white. There's 3 white ones in there, but now there are only 11 marbles in the box. Right? And then lastly, for the green, there's 5 in there, but now there's only 10 in the box. And so if we multiply those together, we get this is a 1 out of 22. And then for independent events, so independent events, So the probability of A and B is equal to the probability of A times the probability of B. Right? So we go back to my 7 and my king. So what's the probability of getting the 7 and then the probability and the king? Right? So probability of a 7 and king. So we said this was 1 out of 6. We said this is 1 out of 13. And so we end up with 1 out of 78. And with that, that will conclude this video.